This is Calculus lesson number 12 in Tier 5 on some final thoughts on derivatives. Well, the first obvious application of derivative is when someone wants to know the rate of change of some function. And by that we mean the slope of the tangent line of each point on the graph of the function. Now this comes up an awful lot in all sorts of STEM subjects. And in fact, indeed, in any subject where one is performing a quantitative analysis of some process. A function is created as a model for some phenomenon that one is studying. And then the rate of change is calculated using differential calculus or the derivative. Now the second application of derivatives, which was vitally important in what I call the old days, was in the graphing of functions. As we learned, a graph of a function is the quickest way to really understand the behavior of a function, and consequently to understand the phenomenon that this function is modeling. So graphs are extremely important. Now historically, graphing functions was very tedious and very time-consuming, and it consumed a great deal of the differential calculus training. Now when graphical calculators came along, that mitigated this and helped, but you still had the problem of finding the maximum and the minimum, and to do that one had to find the zeros of the derivatives, and that alone could be quite difficult, because some derivatives are very difficult equations to solve to find the roots of. And then, of course, we had to apply other tests to determine which of these critical or stationary points, as they're called, were maximum or minimum, or perhaps just points of inflections. And of course, derivatives can be used to determine when the function is increasing or decreasing. And derivatives also can be used to determine concavity and points of inflection. But as you've now learned today, tools like Wolfram Alpha obviate the need for these classical manual procedures. In fact, you can now graph any function virtually instantaneously, and that includes functions whose graphs were essentially intractable to graph historically. In fact, we had to limit the functions we graphed historically to ones that we could handle manually. Furthermore, as you know, Wolfram Alpha will find the stationary points, the points of inflection, determine where things are concave, up or down. It will also determine the asymptotes. It also determines the roots of the function. So Wolfram Alpha gives you all of the information you would ever want to know about the behavior of a function graphically and all of the critical elements about it. As a matter of fact, what is now obvious to you, no doubt, is that a significant percentage of the manual graphing techniques that were taught in the classical calculus courses are now effectively obsolete. In fact, no modern employer is going to pay you to apply these old-fashioned classical techniques. Now, they were great for our ancestors. They were wonderful. It's what built the modern civilization we live in. Before these modern tools like Wolfram Alpha, these classical tools were fantastic, but they are just simply no longer needed. Sometimes it sounds like I'm selling Wolfram Alpha, but of course, as you know, Wolfram Alpha is free. What I'm selling is for you to learn the most modern, effective ways to solve the problems you're going to be faced with in calculus and other mathematical subjects. Now, a third, and in fact in some ways more important application of derivatives is going to be in calculating what we call integrals, which of course you're going to be learning about now in the second half of this course. So-called antiderivatives are extremely important in many science and engineering applications involving integrals. In fact, as you're going to learn, antiderivatives are what we use in integral calculus thanks to the fundamental theorem of calculus. So this is an extremely important application of derivatives you're going to be faced with in the future. And of course, as you might imagine, Wolfram Alpha is going to be an extremely valuable tool in this context. Now, a fourth application of derivatives, as you've learned, is in the representation of functions as infinite series. The most common one known as Taylor series, which you learned about in a previous lesson. But this, in turn, is what makes complex numbers and what is called complex analysis, which is really calculus over the complex numbers, really work. And that's extremely important in STEM subjects, and so this is getting you prepared for that more advanced mathematics, which will be extremely valuable as you proceed in your STEM studies. And now what is perhaps most important of all, derivatives are utilized in what are called differential equations. And these are the workhorses of modern science and engineering models. And this is what you're going to learn all about in Tier 6. Now, if you go into any STEM subject or any other subject utilizing quantitative analysis, you're going to be utilizing differential equations. Now, fortunately today, tools like Wolfram Alpha make this calculation with derivatives automatic. And so whether you're dealing with the applications we've discussed or differential equations or integral calculus, you're going to find it's very easy. And you'll be able to focus on the meaning and their applications. Historically, one often had to avoid certain problems simply because we didn't have the tools to solve them. Indeed, many of the problems that are in calculus books and in science textbooks are rigged up so that we can solve them with the old classical manual tools. But today, with tools like Wolfram Alpha, we're no longer restricted like this. Today, we can solve virtually any calculus problem that's going to come up in any application, and we can solve it quickly and easily. As a matter of fact, I think Wolfram Alpha reduces the workload of applying calculus and differential equations to STEM subjects by probably a factor of 90%. As a matter of fact, I believe that Wolfram Alpha does for calculus and differential equations what the scientific calculator has done for arithmetic, and what the spreadsheet, for example, does for modern accounting and data analysis. Now, as you all know, the scientific calculator does all the arithmetic you need to do in practical math. That's why we're able to master the relevant subjects in algebra and geometry and trigonometry for practical mathematics in about 50 hours a time, maybe one semester. It's because the scientific calculator does all of the drudgery that we had to do classically. Well, Wolfram Alpha does that for calculus. Now, as a STEM professional, you're going to be finding applications of derivatives all the rest of your life. There are literally an unlimited number of examples throughout all STEM subjects. It's quite imperative that you master a tool such as Wolfram Alpha. This is going to be even more important and significant, as you're soon to find out, when you learn integral calculus. You're going to be absolutely amazed at what you can do with Wolfram Alpha. And those of you that know integral calculus and have learned the old-fashioned classical ways of doing it are going to be totally blown away, as I was, by what Wolfram Alpha does for integral calculus. As a matter of fact, I estimate that Wolfram Alpha eliminates as much as 75% of the required work to master the concepts and to implement calculus compared to the classical approach, which unfortunately is still being utilized today in many of our calculus courses. Now, that's why this entire calculus program, this Tier 5 program, can be comfortably completed in about one semester. In fact, I consider it now basically sinful to teach calculus in the classical way when you can use a tool like Wolfram Alpha. Many students flunked calculus when it was taught in the classical way because it was just so messy and difficult. And today, it really is quite easy with Wolfram Alpha. And now I'd like to compliment you and congratulate you on what you've learned so far and kind of review with you now an overview of what you've learned. This is the Part 1 of Differential Calculus in the Tier 5 Calculus course. First of all, I wanted to be sure you understood our approach to learning calculus, how we were taking a heuristic approach, and then, of course, I gave you the calculus overview. Then, of course, you learned about functions, about their terms, about how to graph them, and so on, and examples of graphs, and that's when you began to really appreciate Wolfram Alpha and how powerful it was, because you really learned to graph functions now before you learned any calculus at all. And then, of course, we looked at additional examples of functions, so you were learning about Wolfram Alpha and how to use it to graph functions before we even began to learn about calculus. Well, then we began to learn about calculus by learning what the derivative is. And of course, we use the concept of infinitesimal to define a derivative and to begin to calculate what the derivatives of various common functions were using this definition. But of course, we also learned how to do it with Wolfram Alpha. And while this was very interesting to understand what derivatives are and to see how you could actually derive the derivatives of various functions, we really learned that Wolfram Alpha always does it for you very quickly and easily and painlessly. Well, then we learned how you could apply derivatives to analyzing the graphs of functions, how you can see where they're increasing, decreasing. You can find maximum, minimum points, points of inflection, and concavity. But we also, while we were learning how derivatives could do that, we were learning how Wolfram Alpha does it for you automatically. And so this was really causing us to appreciate what Wolfram Alpha was doing for us and how important and valuable it was. And, of course, an appreciation for what our ancestors did classically. Then we learned the rules of derivatives. We learned how you can actually deal with derivatives and find other derivatives. We learned the Leibniz rule, and we learned the quotient rule. Very, very important. And then, of course, perhaps most important of all is the chain rule, because the chain rule is extremely important whenever you're working with derivatives, as we learned, and we looked at lots of examples of that. And as always, we use Wolfram Alpha for many of these examples to help us greatly amplify what we can do with these concepts once we understand them. Now, one of the great applications of the chain rule was in implicit differentiation, and that has proved to be very, very valuable in all sorts of areas. For example, when we did inverse functions, we used implicit differentiation specifically to do them. We'll learn about relative rates of change. This is a very important application. Of course, it's a precursor to what you learn in differential equations. And finally, we learned how you can expand functions in a series expansion using a Taylor expansion thanks to derivatives. Now, these are all the things that are classically taught, but we looked at them from a more modern viewpoint. We used infinitesimals to understand them conceptually, and we used Wolfram Alpha then to actually do many, many of the problems to appreciate all the things you could do. And this is what we cover now in the differential calculus course, which is actually quite a bit more in some senses than what is covered in a classical differential calculus course, because we were relieved of all of the drudgery with Wolfram Alpha and could focus on the concepts and the applications. Well, now I'd like to close off this final chapter, chapter 12 in differential calculus, with a final thought of the final thoughts. The next thing we're going to study is integral calculus. Now, integral calculus is actually, in some senses, more important in applications than differential calculus. It's extremely important. Of course, you need to understand derivatives and differential calculus to understand integral calculus. But historically, integral calculus has been quite difficult. Many students flunked out of school because of integral calculus. It's probably got a bad reputation. You may have heard horror stories about it. Well, put your mind at rest. Wolfram Alpha is going to make integral calculus very easy. It's going to do even more for integral calculus than it's done for differential calculus. As a matter of fact, I think you're going to find the study of integral calculus conceptually very satisfying, very easy, and the application is very easy, and it's all thanks to this new marvelous, wonderful tool we're using. So, this is Dr. Dell, looking forward to seeing you in integral calculus and congratulating you on now what you've learned about differential calculus. I'm sure it's going to serve you quite well as you pursue any type of a STEM career.